this is the generator. If you are taking, this is a generator. If you are taking it as a generator, this is nothing but the output, and this is again a turbine. It will be connected here. The output of the turbine, it will be given to the generator. Generator field we are going to represent separately. Sorry. Now generator field, let me represent here. This field is going to control by means of excitation loop, excitation loop. Okay, excitation regulator are so many things it will be there, and there will be feedback loop. It will be given from this point. So this is nothing but the terminal voltage VT. There is a sensor is there, that is nothing but the voltage sensor. Voltage sensor. This will be compared with respect to the reference voltage V reference, and correspondingly one error signal it will be generated. Now here this is nothing but the voltage controller is there. The error signal, if it is required, it will be amplified in this excitation control loop, and then the voltage it will be given to the field of this generator. This loop is nothing but automatic. If it is done automatically, this is automatic voltage regulator. This is, in short, this is also represented as a AVR loop. Now you remember one thing. If it is done, if this voltage correction, if it is done automatically, this is automatic voltage regulator. Otherwise, manually, if you are going to take, or if you are going to adjust the voltage, then this is nothing but the voltage regulator loop. This is nothing but excitation loop or voltage regulator loop. Generally, this voltage regulation, the process of this regulation of this voltage, it is done automatically in the bulk power systems. So that's why this is called as this is AVR loop. This is AVR loop. Now, second one is already we have discussed in the previous modules. Now, from here also we are going to take the frequency, actual frequency. This is the frequency sensor is there. This frequency is a reference frequency. It will be again, there is one more set of this thing is there. This, it will be given to the steam valve. This is nothing but the steam valve, and this is again, it will be given to the turbine. So this is nothing but the steam input. This is nothing but the steam input. So this, how much of steam it will be admitted onto this system, it will be regulated by this valve. This valve again, it will be controlled by the frequency controller. This is nothing but the frequency or error in the frequency. Simply we can call it as an error in the frequency. So how can you generate this error in the frequency signal? So actually whatever this is P plus JQ, real power and the imaginary power. So real power and the reactive power. This is R is the real power. This is nothing but the reactive power. So these two combinedly, it is called as a apparent power. So one thing is S is equal to R plus JQ. R is nothing but the real power. Q is nothing but the reactive power. So the units of this is nothing but this is kVA, and this is kW. This is nothing but the kVAR. So this apparent power, this is nothing but it can be split into two, real power and the reactive power, P plus JK. So this is nothing but the output of this particular generator. So output of this generator, again, this generator output has two feedback sessions. One is to regulate the frequency, one is to monitor the frequency. This loop is nothing but the LFC loop, that is nothing but the load frequency control loop. So in this loop, we are going to regulate the frequency, whatever the output frequency, whether this output frequency is as per our requirement or not. If it is not exactly, then at least you have to adjust the frequency such that this frequency should be within the acceptable range. Now generally this is also an automatic process. So this is nothing but the ALFC, automatic load frequency control loop. Only this A, normally it will be used nowadays because either you can take the frequency or you can take the voltage, whatever it may be, it will be automatically adjusted. So that's why this is the AVR loop. This is nothing but the ALFC loop. ALFC means automatic load frequency control loop. This is automatic voltage regulator loop. So this generator on the left side, this is load frequency control loop, it will be there. On the right side, you can find AVR loop. This is automatic voltage regulator loop. So this is nothing but the generator. This is a brief schematic representation of any three-phase alternator or synchronous generator with its two control loops. That is the frequency, and next one is this is voltage. So now from this representation, we can understand that frequency and the voltage are very critical parameters. These parameters should be within the acceptable limits. Now, why this voltage? Okay, already we have studied about the frequency. Okay, let us forget about the frequency for a while. Now here, in today, we are going to talk about voltage. Why the voltage to be maintained constant? Why? What is the necessity of voltage to be maintained constant? Can anybody respond to my query? What is the necessity of keeping voltage as a constant? At least 2 to 3 points, at least one. Is my question is clear? What is the necessity of keeping voltage as constant? Anila, are you there, ma? Amar Sai, good. Yes, voltage fluctuations damages appliances, right? Anybody? Whether it is correct or not, you leave it. You try to respond. Efficient operation, yes. Any other? Lalit, Shravani, are you there? Anila, are you there, ma? Surges in voltage damages the system. Yes, okay. Any other? Sanket, Sanket, are you listening? Okay. Can you respond to my query? Very good answer. Yes, in your problem only answer is there. Now what he said is just a giant class, right? Power cuts. Yes. Okay, that is my question. Why? What is the necessity of maintaining voltage is a constant? Efficient power operation without damage. Okay. Right. Very good. Anybody from lateral entry? Amar Sai, are you there? Amar, Amar Sai. Yeah. Can you respond? Yes. Can you tell me my your opinion about my query? Why? What is the necessity of keeping voltage constant? Sahiti, when voltages fluctuated frequency beyond limits. Okay. Krishna, what is your opinion, Nana? Yeah, voltage variations damages the equipment. It causes damage to appliances. Okay, right. Right. Thank you for your responses. Now, here there are two things are there. First, voltage should be maintained constant. Why? What is the necessity of keeping voltage as a constant? First, you take your lighting load. Suppose your lighting load is there. You take your bulb. Sanket, I think is more suits for your current problem. Suppose actually as per our requirement, what should be the low voltage capacity to our home appliances? 230 volts plus or minus 6% deviation. So if the voltage is within this range, then nothing will be happen to our load of electrical appliances with respect to voltage value. I'm not talking about the frequency. And Amar Sai, you told that there is a relation between the voltage and the frequency. Now voltage and frequency are, of course, there may be a relation, but the relation is very poor. Now in worstly, if the voltage varies, then only frequency changes. Otherwise, these two parameters are nothing but the loosely coupled. Loosely coupled means even if the variation in the frequency is too bad, then only voltage will be changed. Now this voltage is nothing but this frequency is nothing but it is having a tight relation, tight coupling between the frequency and the real power. The real power changes, then within known time this frequency abruptly changes. So that's why there are some pairs: real power, then frequency, then load angle. That is nothing but the machine angle. So this is the load angle, this is the frequency, this is nothing but the real power. These two are nothing but the strongly coupled parameter. Please don't give me an opportunity to explain about this in future, because already in PSOC only I explained this topic thrice or four times, because already you have studied your power system analysis, where you have studied some load flow analysis, that is nothing but fast decoupled load flow, okay, decoupled load flow studies, Newton-Raphson load flows, Gauss-Seidel, Gauss method. These are the various load flows are there. And last one is nothing but the fast decoupled load flow studies is there. That fast decoupled load flow studies only depends on these parameters. What are the set of parameters strongly coupled? What are the set of parameters coupled very loosely? So based on this only, we might have completed our analysis, power system analysis, especially load flow analysis. So even though again I'm repeating, real power, frequency, and the load angle. Load angle is nothing but directly load. These three parameters are strongly coupled. What do you mean by coupling? Now means even for a small deviation in the load, real power changes. For small deviation in the even real power, frequency also changes. So the relation is these three parameters are highly sensitive to with respect to each other. If load changes, then immediately real power changes, then immediately frequency also changes. So that's why these three parameters are called as the strongly coupled parameters. And one more is there, that is nothing but voltage, then reactive power. Reactive power. Now what are these parameters? So if the reactive power changes, automatically your voltage will also change. This is also nothing but strongly coupled. So if the reactive power changes, who will change? Not the frequency effectively changes, but which one is dominantly changes means the reactive power. For smaller variations in the reactive power, your voltage will be changed. So voltage and the reactive power is nothing but this is the strongly coupled set 1, and set 1 is nothing but real power, frequency, and the load angle. So this is one set of strongly coupled parameters. Second set is nothing but the voltage versus reactive power. Now, if you are taking the voltage versus frequency, loosely coupled. Now, if you are taking the voltage versus real power, loosely coupled. If you are taking the frequency versus reactive power, loosely coupled, like this. This is also loosely coupled changes. So only you remember what are the how many sets are there? Strongly coupled, two sets. What are they? One is the real power, versus load versus frequency. This is the one set of strongly coupled parameters. And second set is nothing but the voltage versus reactive power. The reactive power changes automatically, your voltage will also change. So here what is the role why voltage is to be maintained constant means voltage it will be maintained. You can maintain voltage as a constant by maintaining reactive power as constant. Reactive power as constant. Now, why, how? What are the real power? So, real power is nothing but P is equals V into I into cos pi. So, reactive power, this is represented as Q V into I into sin pi. For smaller loads, suppose if we are taking them for the smaller loads, I means light loads, I mean to say for light loads. And what about the power factor? So otherwise, if you are taking a resistive type of load or resistive, now pi is nothing but, now cos pi is unity, so pi is nothing but how much? 0 degrees. Okay. Now for light loads, if you are taking or for resistive loads, now phase angle between them is 0 degrees or close to 0, not exactly 0, close to 0. Then real power is nothing but directly V into I. So similarly, whatever the Q, Q is nothing but the V into sin pi. This is nothing but sin pi, pi is equal to 0 means sin pi is also close to 0. So Q is nothing but the tending to 0. This is happening to where? Now if it is highly resistive loads. Suppose what is our lighting load? Now our problem started with this. What is our lighting load? Lighting load is nothing but the highly resistive in the nature. So if the highly resistive in the nature, then what about the reactive power consumption? So reactive power is nothing but it will consume very less. So that is reactive power is nothing but the directly close to 0. So if the voltage is not maintained properly, means voltage is not maintained properly means now this is your time and this is your V. So how much voltage we require? 230 volts, 50 hertz AC we require. This is our voltage requirement. So the magnitude and this the frequency is 50. Yes, the magnitude is nothing. Let us assume 230 volts RMS value. Let me take. Then in that cases, as long as if the voltage profile is like this, then your bulb or your lighting load or our candles and lamps will glow effectively. Once the voltage dips, if the voltage starts dips, now if the for the voltage dip means whatever the waveform only, so for 1 or 2 cycles it will maintain 230, but after that if the voltage is dipped means now the magnitude may be less, then after sometimes again it may be re-energized to the previous values. So whatever the dipping period, so this is the dipping period. This is nothing but where you can find voltage dips here. Now during this period the frequency may be same, may not be same, the 50 hertz, but in the generally what happens it remains same. But now if the dip is due to some short circuiting fault, then the frequency will be changed. Otherwise if it is open circuited faults, then almost about 50 hertz remains same. Okay, here I'm not interested about the frequency, I'm interested about the magnitude of this particular voltage. So this magnitude is nothing but the, it is not equal to the actual 230 volts. This may be 200 or 150 volts. Now due to this 150 volts, what happens? Now you can observe our lights. These lights are nothing but the, it will be squeezed like anything. So it will automatically dim, then again it will glow, again dim, again it will glow, dim and glow. So this rate of, with what rate this dim and glow will be changed means now that is based on the frequency. But now the lights will automatically getting dim itself. This is because of the voltage magnitude. As long as the voltage remains constant, then you cannot find any interruption in the brightness of that particular light. So but whenever if you find any deviations in the voltage, now this is I'm talking about the under voltage case. There are two things are there. There are some under voltages and over voltages. Now under voltages means if it is less than 230, then this is called as under voltage. For I am talking about our domestic loads. If it is greater than 230 volts, this is nothing but the over voltage cases. Now if the voltage it will be increased above this rated voltage, that is 230, then there also you can find over brightness from the or at the lights. So this is about the lighting loads. And similarly, if you are taking the machinery loads, in the machinery also, what happens now? Suppose if you are taking our induction motor, in the induction motor, now induction motor is nothing but it is a self-starting device. It is a self-starting device. Now the T starting is nothing but it is directly proportional to square of the voltage, right? So if the voltage it is decreased or if it is low, then what about the starting torque? It is further low. It will be because it is the square of the voltage. Now if the starting torque is, if it is very poor, then the induction motor may not turn on because the sufficient starting torque may not be produced because the if the voltage is low. So these are the different problems you can observe in the industry or in the domestic appliances. So if the starting the terminal voltage or if the voltage is poor, then especially because in the industry, if you could observe, almost about 90% machines are induction machines only. Now in the induction machines, what happens? Why majority of the machines are inductive nature means because the beautiful property these are having is self-starting device. Now if it is a self-starting device, that is the starting torque is directly proportional to square of the supply voltage. If the supply voltage is poor, if the voltage is not maintained properly, if the voltage is lower than the specified value, then whatever the starting torque, it will furtherly decrease the starting torque, it will be getting reduced further. Then this, if the starting torque is poor, this induction motor or induction machine may not a self-starting device. So lot of time you have to wait to pick up the speed. Sometimes it may reach the rated speed or sometimes it may not reach the rated speed. Suppose if this starting torque is not enough, not sufficient to get the speed of that induction motor to the rated speed within a short period, then if that induction motor is used to make some ornaments or any kind of thing, then you can expect okay, that induction motor is started to see or to develop one glass, then it will not give a glass. Instead of glass you may get a plate. So this why means if the voltage is not maintained properly. So because of these, because I have taken our normal regular examples for better understanding. So I think this will help us to say that the voltage one has to maintain constant. Now the deviation, at least acceptable deviation is nothing but the plus or minus 6%. Now this is too worse if we are talking about defense or space related experiments, because in the space related experiments also now loads are different, electronics loads will be there, different electronic loads. Now these electronic loads are, this is nothing but, okay, you have studied SCR, IGBT and MOSFETs. These are nothing but the switching times also you might have studied. The switching times or next commutation period, all these periods are nothing but highly sensitive. So because of this, what happens now, I want to turn off that particular SCR or IGBT or MOSFET at 10 milliseconds. Now if the voltage is not maintained properly, then this may not, you may not turn off or turn on at the instant where exactly you want to turn on or off. This may be delayed by 2 milliseconds or 3 milliseconds based on the current it previously handled. So within these 2 to 3 milliseconds, what happens? Major damage may takes place. So the real time example is already you recently you observed one very bad incident in Srisailam power plant. So might be failure of any one of the device. So failure of the any one of the device. So before going to that, let me explain what is the importance of power electronics. That is nothing but the electronics devices. Now, because we are talking about the power system, now then what is the role of this electronics? See, these electronics devices will give accurate on or off, where exactly if you want to turn on or off, that accuracy you can achieve with the help of these electronics devices. That's why these power electronics devices are used to regulate or control the voltages, frequencies, or power factor, etc. So to regulate, to control these voltages, are that is nothing but voltage you take, frequency you take, power factor you take, or some currents you take. All these are nothing but the electrical parameters. But these electrical parameters you can exactly control, or if you want to regulate the voltage, or if you want to control the frequency, all these things can be achieved with the help of electronics components only. So that is the reason this power electronics subject is very, very important, and it is a part of the power system. Now, what is the role of this electronic components means? These electronics components we are going to use to control or to regulate, to monitor different electrical parameters. So, if the voltage is not maintained properly, these electronics components may not function as per your expectation. So, there may be a chance of malfunctioning or maloperation. If that electronics component is not able to operate any voltage or frequency exactly, then there will be a big threat to the existing power system. So the live example is recently you have seen that Sri Shailam blast in Genco Sri Shailam power plant. So one of the reason is nothing but if the voltage is not maintained properly, so that will be the major problem. So with this I want to conclude that voltage you have to maintain constant. Now, is it maintained? Is it possible to maintain exactly at desired value? No, there may be a deviation of plus or minus 6%. So, this is the brief introduction to the voltage control. Let me go back to our slides. So, this is okay. Now, what is the voltage control? Now this is again, I think we have discussed about this. The voltage is a very important and critical parameter in the power system, and one has to maintain it as a constant. Compulsory voltage you have to maintain constant. Now see here also, suppose if it is a light load. Now if the load is light, now see, light load means the loading conditions are very poor. So heavy loads. Now there are two instances are there. What is the heavy load? Suppose now this is your machine. Now this is the terminals here. Suppose heavy load means what happens? This is some load I am connecting here. So maximum load or too much heavy load. It means there is a short circuiting. So short circuiting is nothing but this is the maximum condition. If it is any two terminals, if these two terminals are short circuited, okay, then whatever the voltage at this point, so it is nothing but zero. Okay, if it is light load means it is almost of all it resembles like open circuit load. If it is open circuit load means voltage is nothing but the max means rated voltage. So it is not open circuit, some 5% load you have pulled onto the system, 5% it means light load you have pulled, then whatever the voltage is nothing but slightly it will be decreased. So that is the point here I have mentioned very clearly. The voltage is normally high at light loads. Yes, now light load means open circuit voltage will be high, and it will be low at the heavy loading condition. So heavy loading means at most in the worst cases how much of load you can pull onto the any machine or any cables or conductors. Now if you create some short circuiting conditions, then it means that now maximum load we have applied onto the system. If the load is maximum, then whatever the deviations in the voltage, if the load is maximum, then the whatever the terminal voltage short circuiting means it will be zero. So that is nothing but the voltage is very low at heavy loads. Low means almost close to zero. This is about this point. And whatever the voltage deviation, just now also we have discussed, now plus or minus 6%, it is the acceptable deviations in the voltage at consumers terminals. So here I want to mention, now knowingly or unknowingly we used and we are habituated to use so many times that low voltage, medium voltage, high voltage, extra voltage, ultra high voltage. These are the different voltage we are going to call, or we might have called so many times the voltages with the different names. Low voltage, what do you mean by that? Low voltage, so low voltage means 100 to 1 kV, 100 volts to 1 kV, and medium voltage is nothing but the 1 kV to 100 kV, and high voltage means 100 kV to 345 kV, and extra high voltage is 345 to 765, and ultra high voltage means it is more than 765 kV. Now here you may ask, sir, if it is less than 100 volts, what is that voltage? Of course, that is also considered. Now this low voltage case, can be considered as the voltage is less than 1 kV. This can also be considered as the low voltage. So the less than this low voltage is also possible in the power system, but majorly the minimum voltage, if you turn on any real-time power system, minimum more than 100 volts only you can see. So that is the reason they have called it as the low voltage, means 100 volts to 1 kV. But even if it is less than 100 volts also, now this is also low voltage only. So that is the reason you can clearly mention, as long as the voltage is less than 1 kV, that voltage is called as low voltage. Now see, these are the different voltage slabs. Now this animated figure explains clearly the relation between the voltage, resistance, and that is nothing but the ohm is nothing but it is a resistance, and this is nothing but the amperes. So what it resembles. Now this is a very beautiful animated thing. I got it from YouTube. See, this is the voltage. Always whenever voltage is there between two terminals. Suppose now between this one to this point there is a voltage. Now voltage is there. Voltage always find, pull some current, so that is nothing but the amps. So is pulling. So who will obstacle, who will create some opposition to this particular current, means resistor, that is nothing but the ohms will oppose. So always he want to hold the current, and at the same instant always volts want to pull the amps through channel, through the conductor. So this is nothing but a simple figure. I think for the better understanding, this kind of figures will create some zeal. So that made me to keep this particular figure here. So next, this is also we have discussed. The voltage of the power supply system must be maintained at a constant value. Otherwise, see, this is the time, this is the time axis, this is the voltage axis. Now here, as long as up to this is the constant. Now there you can see there is a big dip. Because of this dip, what happens? Now accuracy of the system. So suppose if it is not maintained properly, now you might have expected to design something, but are you sure whether you are going to achieve the same thing? No. Why? What made means because of these drastic sudden deviations in the voltage. Now from there onwards, now it might have maintained constant, but actually this is my requirement. So this is nothing but, now this is called as the sag, or voltage dip in the voltage. Now it will not suddenly comes to the change in voltage now drastically, or that might be within short period. Now if we know exactly the time, then we can say that with what rate the voltage has been changed from the constant value to the sag or dip. Now here generally voltages are represented as not only voltages, electrical parameters in the power systems are represented with the per unit values. So if it is constant, means always you have to see that voltage should be at 1 per unit. If the voltage is 1 per unit, the system is okay. Now we are saying so many times voltage dips, or this is nothing but the under voltages, or this is more technically you can call it as a voltage sags. Next one is nothing but the now over voltages. Next one is nothing but over voltages, and next one is swells. Now this is what are these over voltages or swells, and what is this under voltages and sags means. If the voltage is 0.9 per unit or less than this is called as a sags. That is nothing but the exactly under voltages. Swells means this is nothing but the 1.1 per unit and more. So it means 0.1 per unit is nothing but the acceptable voltage. Now with this voltage, our power electronics appliances, not exactly power electronics appliances, but majority of the electrical appliances may get adjust by themselves for this smaller deviation. How much it is? 0.1 per unit. So this 0.1 per unit is nothing but this is an acceptable voltage in the real-time power system. Now, what is the swell? Swell, as per this IEEE standards, if any time if the voltage is greater than 1.1 per unit for 1 minute, then this is called as a swells or over voltages. Next one is under voltages or sags. That is, if the voltage is less than 0.9 per unit, this is IEEE standards only I am telling you. So if the voltage is less than 0.9 per unit for 1 minute, then this is called as a sag. Now these sags and swells both will be happen, but the probability of occurrences of the sags are very high. So normally the disturbances in the power systems are nothing but the voltage sags. Now why I am using these sags are very normally it happens means, so normally what happens, which type of faults will takes place in the power system? Short circuiting faults. Definitely short circuiting fault will create voltage sags in the system. So that made me to give that particular statement. Now sag is nothing but, as per IEEE standard, if the voltage is less than 0.9 per unit, that is called as a voltage sag. Now if the voltage is greater than 1.1 per unit, as per IEEE standard, those are called as a voltage swells. Normally, which type of voltage deviations you can see in the power system means sags only. So because this, the major reason for this voltage sags are nothing but the short circuiting faults. Now if any load is given to an unregulated AC generator, the voltage is nothing but automatically dips. Already unregulated AC generator means the voltage is not properly maintained. If the voltage is not properly maintained means, here just now also I have explained generator and it will have a field. That is nothing but the field. Always there must be a feedback loop. This feedback loop always monitors the voltage. Now unregulated AC generator means, now this voltage or excitation loop is not properly maintained. In that cases, then if you are pulling some load onto it, then what happens? Already the voltage is nothing but the VT is very poor because it was not properly adjusted, as there is no effective excitation loop on the system. Again, if you are pulling some load onto it, what happens? This terminal voltage is furtherly decreases. So that is the reason now this waveform have been presented to you for better understanding. Now, who will monitor this voltage? Now, why do we need them? Why do we need them means, already we have discussed so many issues, real-time issues. Otherwise, a voltage dips you can see with the sudden connection, or suddenly if you are throwing some load, suddenly if you are releasing some load, you can observe. Suppose, normally I used to give the same example. Suppose if you are connecting some three-phase power circuit, or to heat some water, or some, if you want to apply, add some three-phase load in your domestic appliances, you can see the differences in your lighting loads. Now whenever you are switch on that particular thing, then at that instant for a shorter period, that light, that illumination or the brightness is slowly decreases. Now whenever you are switch off that particular lighting, switch off that three-phase load, then again it will regain its own brightness. So this is the case. And the automatic voltage regulator, just now also we have discussed, AVRs are nothing but automatic voltage regulators are used to represent or to maintain the voltage as constant. This is nothing but it is a control strategy. Now here also again, what are the main causes of voltage variations? Now what are the main causes means, if you are suddenly throwing some load onto the system, or suddenly if you are opening some load, releasing some load from the system, there will be a change in the voltage. Now that will be severely affected the consumer's premises if the load is not, if the voltage is not properly maintained. So one best and thing you can observe in the, especially in the villages or the roadside, there will be a capacitor bank, white one. It will be placed on the distribution poles, that cement poles. On the cement poles, you can find some a box like this, a white box. It will be connected like this. So this is nothing but called as a capacitor banks. These capacitor banks, what is the need of these capacitor banks? capacitor banks will supply reactive power to the system. Now, if the reactive power is properly maintained, then voltage will also be maintained properly. So these capacitor banks ultimately sees that voltage is constant. And one more important thing, if voltage is not maintained properly, especially in the transmission line losses, in the transmission line, the losses are directly proportional to the voltage. If this voltage is decreases, if this voltage is not maintained properly, then automatically losses will also increase. In view of this, at regular intervals, capacitor banks or series capacitors and transformers will also be placed. What is the need means, if that voltage is not maintained properly, then transmission line losses will be increased. So that is the reason these capacitors are placed in the transmission line losses at regular intervals. As per my knowledge, if I am not wrong, in the especially in the distribution system, at a regular intervals of 6 kilometers, capacitor banks will be placed, because this is nothing but it is a ideal distance. Now, even if it is not placed capacitor banks at this distance, then you can find a voltage dip at that particular point. So whatever the ideal distance to place the capacitor banks means, 6 kilometers is nothing but the ideal distance, especially in the distribution systems. Now, if the load on the system increases, the voltage at the consumer terminals falls due to the increased voltage drop. So voltage drops also we have studied. This especially you can observe in the synchronous impedance. The drop you can see in the impedance drop, and some losses in the transmission line. That is, losses are nothing but it seems to be a voltage drop. So, and next one is the transformer impedance. Also, it will be drop. Feeders and distributors. I have explained about these distributors with the real time. So, at 6 kilometers, compulsory you have to place one capacitor banks. So, next thing is over voltages. Now, I think over voltages and under voltages we have discussed. Over voltages and under voltages. What are these over voltages? Sudden interruption of heavy load. Now, suppose heavy load suddenly if you are released from the system. Now, if you are releasing some sudden load from the system, what happens? You can see some over voltage from the system. These we have studied in electrical machines also, over excitation machines, under excitation machines, all these things. So what are the reasons for this over voltages means? Lightning impulses will be there. So there will be a lightning arrestor in electrical systems. Otherwise what happens, that impulse it will be penetrated into the system. It will cause very adverse effects on the system. So lightning impulses are very important. Impulse means very short duration electrical pulse. So, but it will have very larger magnitude, but it will be there in the system for very shorter durations. And switching impulses will be there. Switching impulses means sudden opening or closing the switches, electrical switches. This will also create some over voltages in the system. Now, single line to ground faults. This is also one of the important problem you can see for the over voltage. These are the different causes for over voltages. Similarly, under voltages also, closing and opening of the circuit breakers. I think in power system protection, you might have studied restriking voltage, all these things. Now this talks well about the under voltage and due to the motor starting. Now suppose if the motor is suddenly started, just now also I have given that example. Suppose if you turn on your borewell in your home, at that particular instant, if you closely see the intensity of that particular bulb, you can find the difference. So that is nothing but how much of time? For shorter duration. Similarly, this happens whenever you are going to turn off your borewell pump also. So at that two instance, you can see the differences in the intensity, light intensity. So with the help of this, we can say that closing and opening of the circuit breakers, and due to the motor starting and stopping, equipment failure. And next one is the construction activity. Construction activity means, but actually in our India, what happens, majority of the transmission conductors are overhead only. But in the underground cables, now not only in the underground cables, overhead cables, overhead conductors also, whenever construction activity, suppose if they are going to change our load from one phase to the another phase, this kind of activities will also cause some under voltage. These are the major causes of over voltages and under voltages. So, and one more thing is, so ultimately this importance of voltage control, uh, everybody, I think everybody knows that the life of the lamp or life of the electrical appliances will also gets reduces if the voltage is not maintained properly. And if the voltage, if supply voltage decreases by 6%, eliminating power may decrease by 20%. So what it happens if this is not properly maintained, not properly corrected, so unnecessarily you have to pay extra amounts for this power illumination, especially in the lighting loads. This is nothing but for lighting loads in incandescent lamps especially. Now 6% above, if the supply voltage is 6% above, then the life of the lamp may be reduced by 50%. Okay, if you are taking a lamp, if it is operates well for 1 day or 10 days, then if this power fluctuations takes place, it may be reduced 50% of its life. So that is the reason now the voltage is to be maintained constant. Now we have discussed about the induction motors also in the beginning of today's class. Now if the supply voltage is above the normal, the motor may operate with a saturated magnetic circuits. Now there will be magnetizing currents. That magnetizing current I naught is nothing but working component plus magnetizing component. This is nothing but the no load current. So this type of this magnetization current is nothing but it depends on the voltage. This working component current is nothing but it depends on the current and the power factor. Now this voltage is nothing but magnetization current. If the voltage is not maintained properly, magnetization current will also drastically differ. So heating and low power, so many things will be there. And if the voltage is too low, it will reduce the starting torque of the motor considerably, because in the beginning only we have discussed that starting torque is the square of the supply voltage. If the voltage is very poor, then your starting torque also very less. So if the starting torque is very less, then the voltage may not be capable. So starting torque is poor means your motor may not turn on. So that is a major why they, because of this, these are nothing but the voltage we have to maintain constant. Otherwise you can see all these problems. So this absorption of the real power and the reactive power, that we will discuss in the next class, because from here onwards actually I am going to enter into the syllabus. Now see, I want to share you, because the major thing here is we are going to adjust the voltage with the help of capacitor. The capacitor is very important. I want to share you something, the working principle of the capacitor. You pay some attention. I think this link is visible to you all.
Imagine 10 years ago, you had the chance to get your share of one of the internet startups worth billions today. Would you have contributed? Sure you would. Hello, my name is Alexander, and I'm one of the co-founders of Living Packets. We have
Are you able to see this capacitor man construction?
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be looking at capacitors.
Are you able to see this video?
to learn how they work, where we use them, and why they're important. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Do not touch the terminals of a capacitor as it can cause an electric shock.
Now you tell
So
me.
what is a capacitor? A capacitor stores electric charge. It's a little bit like a battery, except it stores energy in a different way. It can't store as much energy as a battery, although it can charge and release its energy much faster. This is very useful, and that's why you'll find capacitors used in almost every circuit board. So how does a capacitor work? I want you to first think of a water pipe with water flowing through it. The water will continue to flow until we shut the valve. Then no water can flow. However, if after the valve we first let the water flow into a tank, then the tank will store some of the water, but we will continue to get water flowing out of the pipe. Now when we close the valve, water will stop pouring into the tank, but we still get a steady supply of water out until the tank empties. Once the tank is filled again, we can open and close the valve as many times as we like. As long as we do not completely empty the tank, we will get an uninterrupted supply of water out of the end of the pipe. So we can use a water tank to store water and smooth out interruptions to the supply. In electrical circuits, the capacitor acts as the water tank and stores energy. It can release this to smooth out.
So even in the previous slide, even if you are going to turn off the supply, I mean to say the main valve, so up to some extent the water stored in the tank is solve our purpose. So like this, the capacitor is nothing but that water tank is resembles our capacitor. That's the meaning of this.
Without interruptions to the supply. If we turned a simple circuit on and off very fast without a capacitor, then the light will flash. But if we connect a capacitor into the circuit, then the light will remain on during the interruptions, at least for a short duration, because the capacitor is now discharging and powering the circuit. Inside a basic capacitor, we have two conductive metal plates, which are typically made from aluminium or aluminum, and these will be separated by dielectric insulating material such as ceramic. Dielectric means the material will polarize when in contact with an electric field, and we'll see what that means shortly. One side of the capacitor is connected to the positive side of the circuit, and the other side is connected to the negative. On the side of the capacitor, you will see a stripe and a symbol. This will indicate which side is the negative. If we were to connect a capacitor to a battery, the voltage will push the electrons from the negative terminal over to the capacitor. The electrons will build up on one plate of the capacitor, while the other plate in turn releases some electrons. The electrons can't pass through the capacitor because of the insulating material. Eventually, the capacitor is the same voltage as the battery and no more electrons will flow. There is now a build-up of electrons on one side. This means we have stored energy and we can release this when needed. Because there are more electrons on one side compared to the other, and electrons are negatively charged, this means we have one side which is negative and one side which is positive. So there is a difference in potential or a voltage difference between the two. You can measure this with a multimeter. Voltage is like pressure. When we measure pressure, we're measuring the difference or potential difference between 2 points. If you imagine a pressurized water pipe, we can see the pressure using a pressure gauge. The pressure gauge is comparing two different points also, the pressure inside the pipe compared to the atmospheric pressure outside the pipe. When the tank is empty, the gauge reads 0 because the pressure inside the tank is now equal to the pressure outside the tank, so the gauge has nothing to compare against. Both are the same pressure. The same with voltage. We're comparing the difference between 2 points. If we measure across a 1.5 volt battery, then we read a difference of 1.5 volts between each end. But if we measure the same end, then we read 0 because there's no difference. It's going to be the same. Coming back to the capacitor, we measure across and read a voltage difference between the two because of the buildup of electrons. We still get this reading even when we disconnect the battery. If you remember with magnets, opposites attract and pull towards each other. The same occurs with the buildup of negatively charged electrons. They are attracted to the positively charged particles of the atoms on the opposite plate. They can never reach each other because of the insulating material. This pull between the two sides is an electric field, which holds electrons in place until another path is made. If we then place a small lamp into the circuit, a path now exists for the electrons to flow and reach the opposite side. So the electrons will flow through the lamp, powering it, and the electrons will reach the other side of the capacitor. This will only last a short duration though until the buildup of electrons equalizes on each side. Then the voltage is zero. There is no pushing force and no electrons will flow. Once we connect the battery again, the capacitor will begin to charge. This allows us to interrupt the power supply and the capacitor will provide power during these interruptions. So where do we use capacitors? They look a little bit different, but they're easy to spot. In circuit boards, they tend to look something like this. And we see them represented in engineering drawings with symbols like these. We can also get larger capacitors, which are used, for example, on induction motors, ceiling fans, and air conditioning units. We can get even larger ones, which are used to correct poor power factor in large buildings. On the side of the capacitor, we will find two values. These are the capacitance and the voltage. We measure capacitance of the capacitor in the unit of farads, which we show with a capital F, although we will usually measure a capacitor in microfarads. With microfarads, we just have a symbol before this, which looks something like a letter U or a tail. The other value is our voltage, which we measure in volts with a capital V. On the capacitor, the voltage value is the maximum voltage which the capacitor can handle. We've covered voltage in detail in a separate video. Do check that out, links down below. As I said, the capacitor is rated to handle a certain voltage. If we were to exceed this, then the capacitor will explode.
Hi, have you always wanted to learn to code but don't know where to start? Would you like to make amazing websites and apps and bring your ideas to life? Then this is your course on web development. From beginner to advanced, programming is the most in-demand skill.
So I think this has given some basic function of capacitor, because in the forthcoming sessions we are clearly talking, we are going to talk about this capacitors and its functions only. With the help of this capacitor only, we are going to regulate voltage, not only voltage, power factor, etc., etc. That, because of that only, I have shared this simple video for better understanding. So thank you very much. If you have any doubts, you can ask me. Otherwise, we will close the session today.